Welcome to the world of computer graphics, esteemed learners. So coming to today's session, we will be dealing with ellipse and different ellipse generating algorithms. To start with, what is an ellipse? Ellipse, it is nothing but the extracted part of the circle. It is just a modified circle. A modified circle whose radius varies from a maximum value in one direction known as major axis to a minimum value in the perpendicular direction known as minor axis. So, radius varies from a maximum value in one direction. So, maximum value in one direction is nothing but known as major axis. Minimum value in a perpendicular direction is nothing but known as minor axis. So you can view this in the figure as such. F1 and F2 are nothing but known as fixed positions, or it is also known as foci of the ellipse. That is foci of the ellipse. So F1 and F2 are denoted as fixed positions, and D1 and D2 are denoted as distances. So that is D1 and D2 are nothing but denoted as their distances for the point P, that is x and y. So P is equal to x and y. So P is a point which has coordinates, which has positions such as x and y. So the sum of the two distances D1 and D2, as I mentioned, D1 and D2 between the fixed position F1 and F2, also known as foci of the ellipse to any point P. So P is represented as point on the ellipse is the same value, that is denoted as D1 plus D2. So the sum of two distances are denoted as D1 plus D2 is equal to constant. So ellipse properties. Some of the ellipse properties are expressing distances D1 and D2 in terms of the focal coordinates, that is F1. The first focal length or the fixed positions is equal to x1, x2 and f2 is equal to x2, y2. So f1 is equal to x1 and x2 and f2 is denoted as x2, y2. So with these coordinates, we frame the equation as x1 minus the square root of x1 minus x minus x1 whole square plus y minus y1 whole square plus the square root of x minus x2 whole square plus y minus y2 whole square is equal to constant. So that is x1 plus y1 square root of x1 plus y1 plus x2 plus y2 is equal to constant. Again I will repeat, for the focal coordinates f1 equal to x1, x2 and f2, x2, y2, we have the equation as square root of x minus x1 whole square plus y minus y1 whole square plus square root of x minus x2 whole square plus y minus y2 whole square is equal to constant. So that is D1 plus D2 is equal to constant. So you can have a look here. Fx represents the x-axis and Fy represents the y-axis. So Cartesian coordinates are represented as x minus x naught by Rx to the square plus y minus y naught by Ry to the square is equal to 1. So x minus x naught by Rx to the square plus y minus y naught plus Ry by to the square is equal to 1. So polar coordinates, that is R is equal to x naught plus Rx cos theta. So cos theta represents the x-axis and sin theta represents the y-axis. So x is equal to x naught plus Rx cos theta represents the x-axis, y is equal to y naught plus ry sin theta represents the y-axis. So coming to the ellipse algorithms, symmetry between coordinates are needed. Not symmetric between the two octants of a coordinate. That is not symmetric. There is no symmetry between the two octants of a quadrant. Thus, we must calculate pixel positions and then we obtain positions in the remaining three quadrants by symmetry. Again, the same way, you take four faces, that is, four distributions of different combinations of x and y coordinates. So the first coordinate can be xy, the second coordinate can be x minus y, the third coordinate can be minus x minus y, and the fourth coordinate can be minus xy with different three coordinate combinations. So where x-axis and the y-axis are represented using rx and ry. So ellipse algorithm follows f of ellipse x comma y is equal to r square x square plus r square y square minus r square r square. So the decision parameter, whether it is inside the boundary or outside the boundary or on the boundary. So when you compare the values of f of xy, when the values of f of xy, it is less than 0. If xy coordinates are less than 0, it means it is inside the boundary of the ellipse. If the xy values are equivalent to 0, then it is on the ellipse boundary. If the xy values are greater than 0, it means it is outside the ellipse boundary. So you can consider when slope is equal to minus 1, that is n is equal to minus 1. When it is n is equal to minus 1, x value is from 0 to a and y value is exactly half the value of x. So when x value is 0, 1, 2, 3, 4, 5, 6, 7, 8 for different variations of circle, different variations of an ellipse, then y value exactly is half the value of x when slope is equal to minus 1. So slope is derived as slope is equal to dy by dx, which is equal to minus 2r square x plus 2r square y. So ellipse algorithm follows when slope is equal to minus 1. The same way, slope is equal to minus 1 when the given values for x, y value is exactly half the value of x. So starting at 0, ry, that is with respect of y-axis, we take unit steps in the x direction until we reach the boundary between region 1 and region 2. Then we take unit steps in the y direction over the remainder of the curve in the first quadrant. At the boundary, dy by dx is equal to minus 1. So dy by dx is equal to minus 1, that is 2r square x is equal to 2r square y. Therefore, we move out of region 1 whenever 2r square of x is greater than or equal to 2r square of y. So coming to the polygon. Again, polygon is also one of the scan primitive system. So here, as I have said, it is nothing but it is consideration of combining the different output primitives to form the complex primitive. As I have explained earlier, point and lines can be a simple polygon and point and lines can be a simple primitive, and curves, conic sections, polygon, ellipse and different curved sections can be a complex primitive. So to start with, what is a polygon? polygon actually is connected with the last point to the first point. So the last point and the first point is connected with 3 or more vertices. So it is nothing but a planar shape defined by a sequence of 3 or more vertices connected by line segments known as edges. So each edges are connected on a planar surface so that each edges and connected frames a vertices. So our vertices are connected so that point is nothing but known as edges. So to begin with, some of the functions of polygon which is widely used in OpenGL package is GL begin, GL line loop. So GL begin, GL line loop is GL vertex 2D. So GL is nothing but graphic library. To begin the GL line, just a line, you have to have a vertex of x1, y1, GL vertex 2D of x2, y2, GL vertex 2D, x3, y3, GL vertex 2D, x4, y4, and then give the function known as GLN. It actually forms a bow tie polygon, as you can view that in the diagram. So the first one is bow tie polygon, which I have already explained using the GL begin function, which comes widely in the OpenGL package. So to create a bow tie polygon, this function has to be written. So the same way, to create one more planar shape surface, one more function known as GL begin, GL polygon n. That is GL begin, GL polygon is used. So GL begin will start plotting the polygon using GL polygon function. Then you start off with GL vertex 2D, x1, y1, GL vertex 2D, x2, y2, GL vertex 2D, x3, y3, GL vertex 2D, x4, y4, then end GL, that is GL end. So the first function actually represents the bow tie polygon. The second function, that is GL begin, GL polygon, represents the planar shape surface. Then coming to the regular polygon, vertices uniformly distributed over a circle is nothing but known as regular polygon. As you can view in the diagram, each and every vertices are uniformly distributed. The sides are similar. The same size, the same vertices will never differ in length or sideways. So that is uniformly distributed over a circle is nothing but known as regular polygon. So it is represented as Pxi, Pyi is equal to r cos of I2 pi by n, r sin I2 pi by n, and close the braces when I is equal to 1 to n. So when I is equal to 1 to n. So you can view different polygon surfaces, different planar surfaces with the vertices as well as the edge and the position at the center known as R. So splitting the concave polygons. So what are these concave polygons all about? So concave polygons, and you have a convex polygons. So here walk along the vertices. So vertices can be the points which you join, and those joining points are nothing but known as edges. So determine if corner is convex or concave. So with a simple example, I'll explain how concave and convex polygon differ. Suppose the angle Pi minus 1, Pi plus 1 is concave. So you have 3 different angles as shown in the figure as Pi plus 1, Pi minus 1. Split the polygon along the line through Pi minus 1 and Pi. So split the polygon along the line through Pi minus 1 and Pi as I have drawn a line there. Convex polygon. Repeat, pick 3 succeeding points, any points, join the outside ones with a line. Remove the middle point. Remove the middle point until 3 points are left over. So this determines a convex polygon. So you can see here, repeat the steps. Pick any 3 succeeding polygons. So as I have described here, so you can pick any 3 succeeding polygons. So I have separated with 3 different joints. I have made a different planar surface. Remove the middle point. Remove the middle point until 3 points are left over.